What if every property of the universe you've ever heard of, how fast light moves, how time flows, why particles stay stable, why gravity even exists, all came from just one hidden thing: how tightly an underlying sea of energy is pulled at each place? In the energy filament theory, the universe is not empty space with a few objects scattered inside. It is a churning energy sea whose tension and patterns decide everything we see. And all those separate physical quantities are just different faces of the same tension. The idea is brutally simple: wherever this sea is tighter, physics looks slower and heavier. Wherever it is looser, physics looks faster and lighter. Take light first. It is not a little ball flying out of your lamp. It is more like a ripple running across the surface of the energy sea. A wave bundle squeezed along from one patch to the next. The tighter the sea is pulled, like a drumhead stretched hard, the faster that ripple can propagate. If the sea is slightly relaxed, that ripple's true relay speed is lower. You might jump in and ask, if the true speed of light can change with tension, why do we always measure exactly the same number? Because the rulers and clocks you use to measure it are also built from the same sea and get retuned with it. Atoms set the length of your meter and the tick of your second. And when the sea tightens, they shrink a bit and tick more slowly. So you and your instruments are rescaled together with light by the same invisible hand. And the ratio distance over time stubbornly comes out the same. Light looks constant not because the universe carved a magic number into stone, but because all three lights, your ruler and your clock, are jointly reset by the local tension. Now look at time. Instead of a separate dimension flowing outside everything, it is just the visible face of internal rhythm. Inside every particle, internal structures in the sea are trembling and cycling. Those tiny vibrations are its beat. When the sea is pulled tighter, each cycle takes more effort and runs slower. When the sea is looser, the same cycles flick by more easily and the beating speeds up. So, time passing is really rhythms ticking. And near something like a black hole, time does not literally wrinkle. The internal beats of particles are dragged down. Slow beats look like slow motion, fast beats look like fast forward. Mass then stops being a mysterious build and label and becomes a relationship. Traditional textbooks say mass is an intrinsic property. More mass means more gravity. But here mass is how deeply a structure has cinched the sea around it. Imagine the sea as a flexible sheet. A shallow dent is easy to push around. A deep dimple is stubborn. If a configuration pulls the sea very tight in its neighborhood, it sits in a deep tension pit. And to push it from a tight region into a looser one, you must fight the sea's grip on it, which shows up as hard to accelerate. Big mass is not a lot of stuff stuffed inside. It is sitting very deep in the sea's tightening. Gravity in this picture is simply the slope between tighter and looser regions. Whenever the sea grades from more tight to less tight, it forms a natural downhill. And all structures, large or small, slide along that downhill. From far away you say they attract each other, but what really happens is they are just following the slope. On top of tight versus loose, the sea can also be combed into long directional grooves. On the microscopic scale, these grooves are what we call fields. The electric and magnetic fields around an electron are simply rings and lines where the sea has been pulled into fine directional patterns. And those patterns bias how nearby particles move. A test charge does not decide freely where to go, it slips along those tension lines. On the cosmic scale, the grooves stretch into huge strands and junctions that become the true skeleton of the universe. Galaxies are not sprinkled randomly like sugar on a table. They sit along filaments and nodes of a cosmic web because those filaments in the energy sea were laid down first, and matter only slid along them afterwards. Just as dust and water follow existing cracks and channels in dry mud. Put all of this together and the universe's complicated behavior collapses into two core rules. Wherever the sea is tighter, time runs slower, effective mass is larger, gravity stands out more strongly. Whichever way the grooves are laid, light bends that way, matter drifts that way, and galaxies assemble there. What we call fundamental constants are just the numbers we read off in this particular stretch of sea, where its tension and texture happen to be stable over the range of our experiments. Changing regions or eras and the underlying tensions could be different. Yet every local measuring tool would quietly retune with it, so you would still report the same constants. The universe does not need a dozen unrelated laws sitting side by side. It needs one deep rule. The tightness and texture of the energy sea sculpt what we perceive as the speed of light, the flow of time, mass, gravity, and large-scale structure. Tap follow, share it on New Physics, Clear Universe.